Okay, here we go again. Where we last left off, we had done 6 problems on arc length using both degrees and radians, and now we're going to do the same thing for sector area. Okay, so we're no longer looking just for the arc length. We are now looking for the area of the whole sector. So let's look at this number 17 here. Now, as a review, the area of a circle is pi times the radius squared, pi r squared. So the area of a sector, well, you're going to take how much of the circle you've got, which in this case is 240 degrees, and you divide that by 360. And then instead of multiplying by the circumference like we did for arc length, you multiply by the area to figure out the area of the sector. It looks to me like what we've got is 2/3 of the circle, 4/6. We'll see if that ends up being the case. Okay, so we get 240 over 360 times pi r, which is 16, squared. Okay, so 24 over 36, right? Because both of these are divisible by 10, so the zeros cancel there. 24 and 36 are both divisible by, I believe, 8? No, not 8. 12. They're both divisible by 12. So we do indeed get 2/3.
16 squared is 256.
256 pi over 1, and not a whole lot more that we can do with that. There's no canceling here. 256 is just a whole lot of 2's, so we end up with 512 pi over 3, and this is square feet because it is area that we're looking for. Now that took up a lot of space because I had the review on the top, but it won't take up that much space going forward from here. So we're looking for the area of the shaded region. Well, that shaded region is 315 degrees in measure out of a total of 360 degrees. And we're going to multiply that by pi times the radius squared. Degrees on top, degrees on bottom cancel. 315 over 360, that's a tough one.
Here's a summary from answers. Reduce 315 360ths to lowest terms. Find the GCD of numerator and denominator.
Yeah. Okay, so according to Google, this reduces to 7 over 8, which makes sense to me.
14 squared is 196.
Times 196 pi. Let's see, I think 196 and 8 are both divisible by 4, but again, I've been using Google, so I definitely do not have any problem with you using Google or using a calculator or using some sort of other technology to help you reduce these fairly large numbers. I think they're both divisible by 4. I think that 196 divided by 4 is 19. No, 49 is what I meant to say. 200 divided by 4 would be 50. So 196 divided by 4 should be 49 because it's 4 less. Anyway, so what we end up getting is 7 times 49. Well, let's see. 7 times 50 would be 350. Minus 7 is 343 pi over 2. Okay, let's try the next one. Number 19. we get 3 pi over 2 Now, how much is that? How much is 3 pi over 2? Well, it looks pretty clearly to be 3/4 of the circle, but let's actually be sure about that, okay? So we know that there are a total of 2 pi radians in an entire circle. So we're going to take that 3 pi over 2 and we're going to divide it by 2 pi, just like we did with degrees. We're still dividing by the total number of radians in a circle, which is 2 pi. And that's going to tell us how much of the circle we have, but I'm pretty sure it's going to be 3/4. And then we're going to take that and we're going to multiply it by pi times the radius squared. So again, we have proportion and we have area. Notice that radians, though it does make arc length a lot easier, doesn't really make sector area any easier or more difficult. It's really kind of the same. Remember that this is 2 pi over 1. So what we actually mean is 3 pi over 2. Now remember, when you are dividing fractions, and I really hope I've managed to get this through to you at some point during the year, when you divide by a number, you're really multiplying by its reciprocal. So it's actually 3 pi over 2 times 1 over 2 pi, which is the same thing as 3 pi over 2 divided by 2 pi. Times pi times 196. That's a times, not a decimal. And those two are over 1. Wow, that's a lot of stuff, but it's all going to start to cancel pretty quick, okay? There's a pi on the top and a pi on the bottom, so those cancel. Pi divided by pi is 1. And we found out earlier that 196 is divisible by 4, 2 times 2. It was 49, if I recall properly. So let's see, 49 times 3 is 150, minus 3 is 147 pi square centimeters. So the process is always the same. We just simplified it for arc length with radians. Sector area with radians is still basically the same. Number 20, and we can ignore this stuff over here. It's not relevant. We have 19 pi over 12. 19 pi over 12. And we're going to divide that by 2 pi to get our proportion. And then we're going to multiply that by pi times the radius squared. Well, the radius is 12 feet, so that's going to be 144 pi. Okay, let's do some canceling. Pi on the top, pi on the bottom. Pi divided by pi is 1, so that cancels out. 144 divided by 12 is 12. 12 divided by 2 is 6. So we end up with 19 times 6 pi. Let's see, 20 times 6 is 120, minus 6 is 114. So we should get 114 pi square feet. Now, a lot of students have asked me in the past why it is that I put so much emphasis on fractions in my class. Why is it that I won't just let them go? I won't just give you problems that have whole numbers. And this is why. Being able to manipulate fractions makes your life much, much easier, especially since calculators have to be used in a very, very specific way in order to give you accurate answers. When you've got a whole lot of fractions flying around, it can be very easy to accidentally put the wrong thing into the calculator and get a wrong answer without realizing it. You should never write down any numbers that you don't understand. If you don't understand how the calculator got the number it got, you shouldn't be using the calculator. Understanding is more important than getting the answer. That's it for me for today. I'm hoping to get out another fun video for you tomorrow, and then of course it's the weekend. Thanks for watching, and have a great day. Class dismissed.